My viewers, Alexander Mebaya. Today I'm going to teach on how to solve a question on a harmonic conjugate. Now we are given that u function of x and y is equals to 3x squared y plus 2x squared minus y cubed minus 2y squared. Question number 1. Show that u function of x and y is harmonic. So, for us to show that the function is harmonic, for example, we are given u. So, we say that second derivative of u with respect to x plus second derivative of u with respect to y will give us 0. Now, let us differentiate u twice with respect to x and twice with respect to y. So, our u is equals to 3x squared y plus 2x squared minus y cubed minus 2y squared. Now, dx is equals to if we differentiate 3x squared y with respect to x, we get 6x y plus 4x. Because we don't have this function x, this variable x here in y cubed and y squared, this needs to be zeros. Now, second derivative of u with respect to x, we get, if we differentiate 6xy with respect to x, we get 6y plus 4. This is our second derivative of u with respect to x. Now, we differentiate u with respect to y. If we differentiate 3x squared y plus 2x squared minus y cubed minus 2y squared with respect to y, we get 3x squared. We get 3x squared plus, not plus, we don't have y here now, this becomes 0, minus 3 y squared minus 4y minus 4y. If we differentiate u twice with respect to y, we don't have variable y, this tends to be 0, but here you have y. If we differentiate this one with respect to y, we get negative 6y minus 4. This is now our second derivative of u with respect to y. Now, for us to show that the n function is harmonic, we say that second derivative of u with respect to x plus second derivative of u with respect to y must give us 0. We have our second derivative. Our second derivative of u with respect to y is equal to 6y plus 4. Then we have 6y plus 4. Then we have our second derivative of u with respect to y minus 6 minus 4 minus 6y minus 4. This must give us 0. So we have 6y plus 4 minus 6y minus 4. This is equal to 0. So now we have shown that the function of u is function of x and y is harmonic, because its second derivative with the x and its second derivative with the y gives us 0. Now, number 2, we are told determine v function of x and y such that u x function of x and y and the v function of x and y satisfies Cauchy-Riemann's equation. For Cauchy-Riemann's equation, we see that Cauchy-Riemann's equations, we see that du dx is equals to dv dy, dv dx is equals to negative du dy. These are Cauchy-Riemann's equation. There are two. Du dx is equals to dv dy and dv dx is equals to negative du dy. So we have our du dx, which is our du dx is equals to dv dy is equals to dv du dx is equals to dv dy is equals to 6 y plus 4x. Du dx is equals to dv dy gives us its value is 6xy plus 4x. Now, let's ignore our du dx. So, our dv dy is equals to 6xy plus 4x. We multiply, we cross multiply. Our dv is equals to 6xy plus 4x dy. We find integral both sides. Now our v is equals to if we integrate this function with respect to y, we get 6x y squared divided by 2 plus 4xy plus function, let's say function of a. Now our v is equals to 3xy squared plus 4xy. This is, let us call this equation 1. Let's differentiate our equation 1 with respect to x. And differentiate our equation 1 with respect to x. Now dv dx is equals to, if we differentiate with respect to x, we get 3y squared plus 4y. This is our derivative of v with respect to x. I can call it now our equation. We can call it equation 2. Again, dv dx is equals to negative du dy is equals to, for du dy, then we multiply by negative, we will get dv dx. So we have negative du dy 3 into 3x squared minus 3y squared minus 4y minus 4y. Now our dx is equals to, if we open bracket, we have minus 3x squared minus 3y squared minus 4y minus 4y. But we have got not really. We have negative 3, this is positive, and we have negative 4, this is positive. Now, we have our dv dx in this equation 2, and we have dv dx called this equation 3. So, equation 2 and 3, they must be equal. Equation 3 and 2 must be equal because they are all derivative of v with respect to x. So we say 3y squared plus 4y, but here we end the function. Here we end the function after this. We end the function. This is free. Yeah, we end the function. We end that function plus that function. 3y squared plus 4y plus function of a is equals to negative 3x squared plus 3y squared plus 4y. They must be equal. So we have 3y squared and 3y squared, 4y squared and 4y squared. If we take one of them to the other side, we get now 3y squared and 4y squared has to be 0, because if we cross the sum, we have 3y squared minus 3y squared plus 4y squared plus 4y minus 4y. Now, this and this one. Now we have this becomes 0. Now we have the function of x equals to minus 3x squared is equals to 3x squared. Then we integrate with respect to x. We integrate with respect to x was initially we differentiated with respect to x. Now we integrate with respect to x. Our function of a is equals now to minus 6x minus 6x. That is the function of a. Now our v is equals to, take our v is equals to 3xy squared plus 4xy. Then this function, we have the function of y, which is negative 6x, and this is answer. This is the function of this is v function of x and y. So we have to prove whether v and u satisfies quaternion equation. Now we have to differentiate v with respect to x and v with respect to y. So the v dx is equals to 3y squared plus 4x plus 4y plus 4y minus 6. Now again